What is going on, Dr. Ross and STEM 2 class, the rest of the world on YouTube? My name is Brandon, and today I'm talking about interactive neuromuscular stimulation, INMS or INS, uh, and the effects of that technology when used properly on vertical performance. A little bit of background on INS before I go into the weeds of everything. INS, INMS is a subgenre of neuromuscular electric stimulation, not to be confused with TENS or EMS. INS and neuromuscular electric stimulation actually re-educates the nervous system, allowing you to shift from a fight or flight state, a sympathetic state, to a parasympathetic state, a restful state. This will allow you to think and move better. So, the past research that we have seen is mainly with muscle strength, performance, hypertrophy, as well as neuromuscular coordination. So the research gaps are long-term effects. I can tell you anecdotally that I have trained 554 hours per year, and now I only trained 54 hours per year using the technology. But again, that's just anecdotal. So I want to eventually dive into all that research for long-term effects as well. There's no standardization. Everything is very proprietary. So because it's proprietary, there needs to be a standardization on how to use the technology and how to use it properly. Uh, synergistic techniques of what to use the technology with, how to use it, blood flow restriction, and otherwise. There's a wide, diverse population that people have worked with, so that can be kind of confusing too. Muscle coordination, I already talked about that. The problem statement is neuromuscular electrostim shows promise, but there are gaps. So there needs to be a comprehensive approach to use the full potential of the technology. Whew, that's a lot. Let's dive into our hypothesis. Our hypothesis, my hypothesis, is we can increase a vertical within 5 to 10 minutes if there's no uh, outlying neuromuscular conditions uh, that is happening to the athlete, to the person that we are working with. Because we're going to maximize the efficiency of the nervous system, allowing more muscle fibers to unlock. Instead of using 50 to 60% of muscle fibers, our goal is to get all 100% engaged so that way the person can reach their full potential and not be governed by their own thoughts and their body's own stopping points within their body. So we want to elevate the nervous system and using the technology and our techniques, allowing that and replicate that for other people to see. Our biggest conclusion for this is using and redefining uh, the landscape of traditional strength training and rehab. The traditional side is fantastic, but it can always be elevated. Did I start this? I didn't start this. I'm going to start it now. Sorry, I'm recording this on a different device as well, so that way I can use my notes. So, going into the full body research of interactive neuromuscular stimulation, again, the subgenre of neuromuscular electrostim. There's not a whole lot on INS and INMS, but there's a whole lot on neuromuscular electrostim, and there can always be more. So, we're going to go really wide with the research and we're going to narrow it in and then conclude the little video here today. So neuromuscular electrostim has shown enhancements with muscular strength, performance, particular in populations that can't engage in traditional methods. This could be someone with a stroke. This could be somebody that doesn't have great range of motion. This could be somebody with MS. So the key takeaways with this is we're using different methods to give a better result for clients. And then pairing it with something like blood flow restriction can help people rehab faster. Also, pairing it with mental imagery allows for clients and patients to rehab faster. But we've already seen this research in the past, just not with neuromuscular electrical stimulation. So we want to see those enhancements of hypertrophy and neuromuscular function. And we've seen that within this research by both Lynn and Jan Malfatti and Dr. Robert Becker. Uh, Creating standardization protocols are essential for consistent outcomes. So that needs to happen. And using different modalities together will help for the future exploration of neuromuscular electrical stimulation. So going to the second body here, there's been an emerging intervention with rehab with this technology. Post ACL reconstruction is the main thing that we'll talk about here, but there's also going to be stroke. So Lynn and Jan looked at upper body recovery in 46 stroke patients, and they saw significant improvements uh, with those results, getting better motor function, and even with follow-ups not using this technology. Sab and Labib worked on contralateral movements. So not movements, but muscle patterns. So they were working on a right leg and the left leg was getting the results. And we've seen this research in the past showing that if I work on my right leg, there's going to be a 30% improvement in that left leg. We're just enhancing that with the technology with Sabib and Labib. Again, sorry if I butcher any of these names. Um, And then Wright et al. Looked at ARP wave showing ACL reconstruction. So after surgery and reconstruction, they saw a threefold, three times the recovery rate using the technology compared to traditional methods. And anecdotally, we were able to work with a client that did a threefold on ARP waves results. So if it took ARPWave 3 months, it took us 1 month to get the same results. With that being said, there is different techniques, there's different procedures, how the client eats, and again, it's just anecdotal. So we don't have a whole lot to stand on with that. But we want the potential for sample size to continue to increase so that way we can have more future research that is easier to understand and easier to read. And let's just face it, we need to have concrete data for people to understand it. So, going into the third body of research here, we're going into more neuromuscular training with a side of rehab here. So, we want to see the difference in enhancement in muscle strength, endurance, coordination, and physical limitations. So, Vasina et al. In 2022 showed comparable increases um, when they were doing physical exertion compared to high load resistance training, which is great. So it's using the technology instead of resistance training and seeing what's working. And they saw very good results on both. Stability in your ankles when rock climbing was another one. Post injury, I think is what they were looking at, if I remember correctly. I've read a lot of research. But we can see that ankle stability, so that way you can continue to rock climb and perform at optimal levels. And then looking at traditional methods again versus regular methods, we're enhancing those outcomes at a higher level. And that was Blasevich et al. In 2021. So neuromuscular training and ESTIM, or electric stimulation, neuromuscular electric stimulation, in strength training and stability for higher levels, investigating optimization, rehab, and performance practices. Going on to the fourth, body research. This is a critical time for neuromuscular electrical stimulation to show the adaptations, particularly focusing on chronic rather than immediate results. Our goal is to actually show the opposite, but the research here showed those chronic stuff, so like long-term goals. So when we're looking at the long-term adaptations, we can see by Godin et al. And Peeler et al. In 2011 and 2008, respectively, neuromuscular electrical stimulation showed a positive impact on vertical jumping in non-athlete populations. So looking at non-athletes, we want to see if we can increase that vertical. For us, we'll probably want to see what happens with actual athletes. And instead of doing a long-term plan, let's say it's 3 months, we want to do it in 5, 10 minutes. As long as they don't have a neuromuscular uh, deficiency, we should see a greater increase. And investigating those standard results versus uh, the technology results. Using different populations will help in the future. For us, I think we need to focus mainly on one population before we get into the evolving applications of neuromuscular electrical stimulation. My thought with all of this is I can take the research anywhere I want to go, but we really need a narrow focus before we go broad. Um, so it's the actual opposite of what we did with, or what I did with the research bodies in SEM2 here. I say we a lot. I own a business, so there's a lot of we, and this entire project is all me, and it's something that's unique. And I'm looking forward to seeing what we can get and seeing what results are going to come out of this. If you want to look at any of our references, I have this link here, and I will provide it for everybody in the bio. I appreciate your time. Thank you.